Hello students, in this video we'll see an example of computing the area inside a loop of a special polar curve. I'm going to consider the polar curve. Consider r equals 2 cosine 2 theta over the cosine of theta. This one is good to plot on a graphing calculator or on some software. If you plot this function, this polar curve, what you'll see is you're going to get a shape that looks like this. There's going to be a loop over here and an asymptote over here in the second and third quadrants. So our polar curve looks like this. So it looks like this ribbon. And I'd like to find the area inside this loop over here. So the question is, what's the area of that loop? Inside that loop? Well, I need to figure out the limits of that loop. So to do this, we note that when I plug in theta equals 0, when we plug in theta equals 0 to this problem, what will r become? R is going to become 2. So this curve is going to start way over here at the point 2. And then as theta moves from 0 to pi over 4, as theta goes to pi over 4, we see that r becomes 0 because 2 times pi over 4 is pi over 2, and the cosine of pi over 2 is equal to 0. So this curve is going to go from this point 2, 0 all the way back to the origin like so. And then the nice thing about this function over here is that this function of theta is an even function of theta. So by polar symmetry, if I go to negative pi over 4, I will traverse the opposite direction. So our limits of integration in this problem is that between negative pi over 4 and pi over 4 is the loop. Okay, so the loop is between, the loop corresponds to the values of theta that are between negative pi over 4 and pi over 4. So now we can use our area formula. What's our area formula? Our area formula is 1/2 the integral from alpha to beta of r squared d theta. So we're going to have what? We're going to have a 1/2 integral from negative pi over 4 to pi over 4 of 4 cosine squared of 2 theta over cosine squared of theta d theta. So I'm going to do a couple things. The first thing I'm going to do is I'm going to pull out that 4 and then write this as 2, the integral from negative pi over 4 to pi over 4 of cosine squared of 2 theta over cosine squared of theta d theta. And then since this is an even function, I can break the symmetry of this integral over here and write this as 4, the integral from 0 to pi over 4 of cosine squared of 2 theta over cosine squared of theta. And now we can do one trick over here. What I'm going to do is I'm going to subtract off a 1 from this, thereby subtracting a total of what? Thereby subtracting a secant squared, so then I'll add in a secant squared of theta d theta. Great. Okay. Now the reason I'm going to do this, we'll see in a second over here. So what I'm going to observe over here is that this first thing, this integral, is what? This is going to become 4, the integral from 0 to pi over 4. Now I'm going to use power reduction on cosine. I'm going to write cosine squared of theta as 1 plus the cosine of 2 theta over 2. So I'm going to put on the top over here, I'm going to say this first thing is really a factor of 2, and then I have a cosine squared of 2 theta minus 1 over cosine of 2 theta plus 1 for my first term over here, then plus what? Then plus secant squared of theta d theta. Great. Of course, all these things are in big parentheses over here, like so. And now the key thing to observe over here is that this expression over here is really the cosine of 2 theta plus 1 times the cosine of 2 theta minus 1 by factoring. And so the cosine of 2 theta plus 1 will cancel out, and so I get an even simpler formulation of my integral over here. So what does my integral simplify to? My integral is going to simplify to 4, integral from 0 to pi over 4. And then I have a what? Then I have 2 times what? Times the cosine of 2 theta. And then I'm going to have a 2 times negative 1, so that's a negative 2. And then I have a plus secant squared of theta d theta, parentheses and everything. Now as the antiderivative of this, I'm going to have a total of 4 copies of what? Antiderivative of 2 cosine 2 theta is just going to be what? It's just going to be the sine of 2 theta. Let's check that. Of course, the derivative of sine of 2 theta is what? The derivative of sine of 2 theta is going to be cosine of 2 theta times 2, so that works out. Then we have a negative 2 theta. That's easy. And then antiderivative of secant squared is tangent, right? So tangent of theta from 0 all the way up to pi over 4. Great. Now the nice thing is when I plug in 0 to tangent or theta or sine, I get nothing. So the bottom limit is going to be 0. So we're going to have a total of what? We're going to have a total of 4. And then the sine of 2 times pi over 4 is the sine of pi over 2, so that's going to be a 1. When I plug in pi over 4 to this negative 2 theta, I'm going to get negative pi over 2, negative pi over 2. And the tangent of pi over 4 is also equal to 1. 1. So what we have over here is we have 4 times 2 minus pi over 2. And we can distribute this out. This is going to be an 8 minus what? 8 minus 2 pi is the area in that loop of this ribbon polar curve. Thank you very much.